Hi, today we're going to talk about volumes of solids of revolution, how to find them. So let's first understand what solids of revolution are. So we have this region here that we're going to revolve about the x-axis. So if you think about this, you're going to have a segment here, a very thin rectangle, that if you rotate that, it's going to end up giving you a disk, which is going to look like this. This is side view of that. So if you try to rotate the whole thing, your object is going to look roughly like something like that. It's going to be a solid object, like all the way through. Kind of looks like a mug, I guess. Here's a bit of a better representation of that. A little prettier and colorful. It's not completely close, but that's what it is. So when we try to find the volume of a solid that you obtain by revolving a certain region about any horizontal axis, this is the formula that we are going to use. So the formula is pi times the integral from a to b, which are going to be your boundaries for the region, of r of x squared dx. I want to remind you, since we're working with disks, to find the area of a circle is pi r squared, so pi r squared here. Okay, so the important question here is going to be how to find r. Let's take a look at this first problem. Find the volume of the solid obtained by revolving the region bounded by these equations. So what we have here is the curve 1 over x. X equals 1, x equals 3, and y equals 0, which is the x-axis. The first thing we need to do is figure out the radius. So the radius is, when you go from the x, and we're revolving that about the x-axis. So the distance between the axis of revolution and the curve, which in this case is going to be the function itself, correct? Because that's precisely what the height is going to be as. So the radius function here is going to be 1 over x. And now we can set this up to find the volume. Pi times the integral from 1 to 4, these are the boundaries, of our radius function squared dx. That's going to become pi times the integral from 1 to 4, 1 over x squared dx. To help you integrate this, 1 over x squared is actually x to the negative second power. So then when you continue this, the antiderivative here is going to be negative 1 over x, going from 1 to 4, pi times substitute 4, negative 1/4, minus substitute 1, negative 1 over 1. And that's going to be pi times negative 1/4 plus 1. And it's going to become 3/4 pi, or simply 3 pi over 4. So it's pretty simple when the axis of revolution is the x-axis itself, because then the radius is the function. But what if the axis of revolution is not the x-axis? How is it going to change? So let's take a look at that. Here's a problem. We have this region here bounded by all that. So one of the boundary lines here is y equals negative 1, and we're going to revolve it about that. So the easiest way to visualize that is connect, just like we did with the previous problem, connect the axis of revolution with the curve. And that's going to be our radius. So basically what we need to do is find the distance between that point and that line, between this curve at any point. So what is it? It's going to be the difference between the curve and this y value. So the radius function here is going to be the curve x squared plus 1 minus the equation for the axis of revolution, which is negative 1, y equals negative 1. And it all simplifies to x squared plus 2. So now we can set up the volume expression, pi times the integral from 1 to 3 of x squared plus 2 squared dx. we do need to expand this first before we can integrate that. So pi the integral from 1 to 3 of x to the 4th plus 4x squared plus 4 dx. Now you can find the antiderivative. So pi times, this is going to be x to the 5th over 5 plus 4x cubed over 3 plus 4x, going from 1 to 3. Time to substitute the values. So it's pi. First we substitute 3 to the 5th over 5 plus 4 times 3 cubed over 3 plus 4 times 3, and then minus, now we have to substitute 1, so it's going to be 1/5 plus 4/3 plus 4. The rest is just the arithmetic work. We do have to do some operations with fractions. I'm not going to get into the details, but once you get all these done, this is supposed to give you 1366 pi over 15. It's going to be a little bit tedious, but we don't want to spend time on doing arithmetic work here for calculus. There's one more problem. How is it going to change if the axis of revolution is above the region? Is it going to be different? Well, let's see. So we're still dealing with this that's going to represent our radius. It's the distance from the axis of revolution to the curve itself. So to find this distance, it's going to be the distance between this line and the curve. So it's going to be 5 minus quantity x squared plus 1. Remember, you're subtracting a whole quantity, you need parentheses there. So that's going to end up giving you 5 minus x squared minus 1, which is going to be 4 minus x squared. So this is the radius function. Could you have gone the other way and do the curve minus the line? Technically, for the radius, it's not going to be right because the radius will come out to be negative, but because you're going to end up squaring that anyway, once you put it into the volume formula, it is really not going to make much difference. So the volume is going to be pi times the integral, going from 0 to 2, of 4 minus x squared dx. Expand pi times the integral from 0 to 2, 16 minus 8x squared plus x to the 4th dx. Now we can take find the antiderivative. Pi 16x minus 8x cubed over 3 plus x to the 5th over 5 from 0 to 2. Substitute that with one of the limits being 0 and that being a polynomial function. It makes it a little bit nicer. So it's going to be pi. So first we substitute 2. It's going to be 32 minus 8 times 8 over 3 plus 32 over 5. I know we're going to get 0, but I am going to write that. I just want to make sure that we don't forget that there's another limit that we still have to substitute. Okay, and after doing all the arithmetic here, you're going to end up with 256 pi over 15, and that is the answer. As always, if you have any questions, you can put them in the comments. Let me know what else you might need help with. I hope this helps.